Operations on functions. Graphing techniques. Arithmetic operations. By adding, subtracting, multiplying, or dividing two functions, we can form new functions. Suppose f of x is a function with domain P and g of x is a function with domain Q. F plus g of x will equal f of x plus g of x with domain P intersection Q. F subtract g of x equals f of x subtract g of x with the domain P intersection Q2. F times g of x is equal to f of x times g of x with the same domain. And f divided by g of x is equal to f of x divided by g of x with the same domain, excluding values of x for which g of x would be equal to 0. Example 1. If f of x equals the square root of x subtract 7 and g of x equals square root of x subtract 1, find f plus g of x. Well, all we need to do is add the functions, and because they're square roots, we cannot combine them because they have different radicands. So your answer is just square root of x subtract 7 plus square root of x subtract 1. The domain, again, we have to add the domains and we have to determine the domains and find out what they have in common. Well, the domain of the first one would be 7 to infinity, because we put any number less than 7 in, we'll take the square root of a negative number. We can't do that. And likewise, the second one, 1 to infinity, for the same reasons. What do they have in common? Well, they have in common the numbers 7 through infinity, so that is going to be the domain of f plus g of x. Example 2, same functions, but now we're multiplying them. And when we multiply them, we actually can combine them a bit, because we can multiply insides of radicals. You know the square root of 2 times the square root of 3 is the square root of 6. So in this case, we're going to get x squared subtract 8x plus 7 underneath our radical. And our domain is going to be the same thing as for example 1. It's going to be the intersection of the two sets, which is the same thing, 7 to infinity. Function composition. The composition of a function f with function g is denoted f circle g and read f composed with g is defined by f circle g is equal to f of g of x. I rarely read it as f composed with g. The domain of f circle g, or f of g, is the set of all numbers x in the domain of g for which g of x is in the domain of f. Here's a diagram of it. We're not going to spend a whole lot of time on it. Example 3. Given f of x is equal to x squared plus 2 and g of x is equal to 4x subtract 3, find f of g. This just means we're going to substitute our g value in for x in our f value. So we're going to replace x and f of x with 4x subtract 3. So it now becomes 4x subtract 3 all squared plus 2. Square that binomial. You get 16x squared subtract 24x plus 9 plus 2. And simplify it and you get 16x squared subtract 24x plus 11. There's no concern about domain here because they're both polynomial functions who have a domain of all real numbers. Example 4, given that f of 2 is equal to 5, f of 5 is equal to negative 6, g of 2 is equal to 10, and g of 5 is equal to 4, we're asked to evaluate, first of all, g of f of 2. It looks a little confusing with all those values, but just start from the inside. We have g of f of 2. Where you look above, it says f of 2 is equal to 5, so I could replace f of 2 with 5, so I now have g of 5. And if you look at the end of the top line, it says g of 5 is equal to 4, so our answer is just going to be 4. All right, we'll do letter B for this as well, which is f of 1/2 of g of 5. Again, start from the inside. G of 5 is equal to 4, so I now have f of 1/2 times 4. 1/2 times 4 is 2, so I now have f of 2. And we know from the beginning of that line, after the given that, f of 2 is equal to 5, so our answer here is 5. All right, example 5. Again, we got to find f of g and its domain in this case. So all I need to do is replace x in our f function with our g value, or g function, which is 1 over x plus 2. But we'll start by just replacing with g of x. So f of g of x will equal 4 over g of x subtract 1. Replace g of x, we get 4 over 1 over x plus 2 subtract 1. This is what we call a complex fraction, a fraction within a fraction. The easiest way to simplify it is multiplying by a value of 1. In this case, our value of 1 will be x plus 2 over x plus 2. So if I do that, up top I'll get 4x plus 8. Now if I distribute it to the bottom, x plus 2 times 1 over x plus 2, you'll just get 1. Subtract 1 times x plus 2, so you just get subtract x plus 2. So you get 1 subtract x plus 2 on the bottom. Simplify it a little further by going 1 subtract x subtract 2. Combine the 1 and subtract 2, you get negative x subtract 1. Or if we take a common factor of negative 1 out, we just get negative brackets x plus 1. And that negative sign can be moved in front of the fraction now. All right, now we've got to deal with the domain. Well, we know x cannot equal negative 2 because we got a 1 plus x plus 2, 1 over x plus 2 in the denominator there. So it cannot equal negative 2. It also cannot, g of x cannot equal 1 because we have g of x subtract 1 in the denominator of that function. So if I take g of x, instead of not equal to 1, well, g of x is 1 over x plus 2, cannot equal 1. Cross multiply, 1 cannot equal x plus 2, or negative 1 cannot equal x. So our domains can be all numbers except for negative 2 and negative 1. All right. Function decomposition. To decompose a function means to recognize how the function was created by 2 or more functions. So example 5, if g of x is equal to 2x plus 5, find a function f of x so that f of g of x is equal to h of x, and h of x is equal to 2x plus 9. So we want f of g of x. Okay, well, we know g is 2x plus 5, so we have f of 2x plus 5 equals 2x plus 9. Well, think of it in this case. Well, 2x plus 5, all I need to do is add 4 to it, really? So 2x plus 5 plus 4 is equal to 2x plus 9. So really, all I need f of x to be is x plus 4. So f of x equals x plus 4. B, we have h of x is equal to 4x squared plus 20x plus 25. So again, we're going to have f of g of x is equal to that, or f of 2x plus 5 is equal to 4x squared plus 20x plus 25. If you look carefully at this one, you can think, 2x plus 5 has a relationship with 4x squared plus 20x plus 25. All you need to do is square it and you will get that. So 2x plus 5 all squared equals that, which means all we need for f of x to be is x squared. All right, example 6, sketch a graph for y equals x plus 5 squared, subtract 2, using translations. We'll start by graphing the function y equals x squared. Should know this fairly well. Just says vertex at the origin goes through 1, 1, 2, 4, negative 1, 1, negative 2, 4, etc. So draw your sketch. Now, translations. Well, we have x plus 5. If it's x plus 5, it's going to move 5 units to the left. Translated 5 units left horizontally. So what we can do is we can just slide the whole graph there, and you really didn't need to graph the original graph. Just kind of do it in your head. Okay, the vertex is here. I'll move it over 5 units. And now let's deal with the vertical translation. We've got a vertical translation of 2 units down, so the whole thing will shift 2 units down. And there you see your final graph, y equals x plus 5 all squared, subtract 2. All right. When a function f is multiplied by a positive number a, the graph of the new function y equals a f of x is obtained by multiplying each y coordinate by a. The new graph is a vertically stretched version of f if a is greater than 1. The new graph is a vertically compressed if 0 is less than a, which is less than 1. All right, could have 3 graphs here. First of all, we have f of x equals x squared. Notice your coordinates, 2, 4, and negative 2, 4. If I get f of x equals 1/2 x squared, my coordinates are now 2, 2, and negative 2, 2. It's 1/2 as high as it used to be, so it is vertically compressed. And now I've got f of x equals 3x squared, and now my coordinates are 2, 12, and negative 2, 12, because they are multiplied by 3, so it is vertically stretched. When the output of a function y equals f of x is multiplied by negative 1, the result is y equals negative f of x is a reflection of the graph in the x-axis. When the input of a function y equals f of x is multiplied by negative 1, the result is y equals f of negative x is a reflection of the graph in the y-axis. So below you see f of x equals e to the x. You see f of x is equal to negative e to the x, and that's a reflection in the x-axis. And then you also see f of x is equal to e to the negative x, and it's a reflection in the y-axis. And lastly, to accurately sketch the graph of a function in the form of y equals af of b times x subtract h plus k, the stretches and reflections, the a value and a b value, should occur before the translations h value and k value.